Shall we start now? Okay. Can you all see my screen? Okay.
Yes, madam.
Okay. So now we are going to talk about our next one. We already discussed about hierarchical data model, then the network data model. Now we are going to talk about relational data model. In this case, in the relational data model, this is entirely different from the concept in hierarchical and the network model, and this is a collection of table of with data elements. So in this case, that means wait, in hierarchical model, basic data structure or a data element is a table. When we are consider about the table, you can see this is a table. There are some columns as well as rows. So that in this hierarchical model, these tables are known as relations. So hierarchical model, the basic structure is a table. So these tables are known as relations. When we consider about a table is consist with rows as well as columns. So when we consider about a column, this is a column, this is a column, and this is also a column. So these columns are known as attributes or domain. These rows are known as tuples. Okay, there are columns and the rows in a table. The columns are known as attributes and the rows are known as tuples. So you can see these are the, before that, as an example, let's take student. When we consider about student is an entity. In our previous model, this is student in an entity. In this case, this student is a table. In the previous two models, we can take student as an entity, but in this case, the basic structure is equal to table. No? So the student is a table. So when we consider about student table, we can define some characteristics of a student. As an example, you can define student ID, SID, then student name and date of birth, then address. Okay, so you can see there are some characteristics of this student. So these characteristics are known as attributes of the table. So these characteristics are indicated by using a column header, column header. Then let's discuss about one student in this class. I'm get no name, no. Rashmika. I'm take a Rashmika as example. In the Rashmika, she has a student ID S325, likewise Rashmika from Mother, address from date of birth 1961 1, address Mother. So you can see this is a value for this. When we consider about these values, these are the values for these characteristics about one person. So this can be taken as a this can be taken as a tuples. This is equivalent to the records in the, this is also known as a record. So don't mismatch with the, in this case, records in the first one, which one, the hierarchical model, the entities are known as records. So don't misunderstand these two things, but in relational model, these are known as records of tuples. Okay. Okay, ma'am, tuples are known as records. Then you can see this is a table. So what are that? So the project name, project number, and the date start and the estimated cost is the attributes of this table. So these are rows or tuples. This is the first tuple. This is the record, second tuple. So these are the main features available in a relational model. So this table is known as relation. So this is the student relation. Okay. The relation is simply a table. It may have many tuples. A tuple is the best thought of as a record with n field. So this can be any number of fields. So the tables are related to each other by sharing the common characteristics or attributes. Okay, so the before moving into primary key, again in relational model, table is a basic data structure. It is known as a relation. So table is consists with headers and then columns and the rows. Headers are known as attributes and the columns are known as tuples or records. So when we consider about that means entity, it can be taken as a it can be taken as that means relation in the relation model. Then let's discuss about primary key. The primary key is a key which is used to identify a particular, that means the primary key is a key which is used to identify each and every record uniquely. As an example, let's take student. So student ID, then the student name, then about address. So you can see S1, S2, then the S3, S4, name Kamal, then Amal, again Kamal, again another students with Kamal, then Nayan. But these two are different. Both name is same. So this is Nama. So the address is Matara. Then let's take, so this take normally. So this is female, male, 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 Matara, Matara, Candy, then Hego. Like so you can see this is a table which consists with the student ID, student name, address, and the set. So you can see there are 4 tuples or 4 records in this table. These are the attributes of this table. So this is about student relations. So in this case, you can see as a requirement, you need to identify each and every record uniquely. So when we consider about this attribute, this is the S1, this is S2, S3, S4. There are no any duplication values. So we can identify each and every record by using this ID, S1, S2, S3, S4. So we can take this as a primary key. So we can take this as a primary key. Okay. So by using this primary key, we can differ each and every records uniquely. Is it clear? Is it clear about primary key?
Yes, madam.
Okay. So when I'm going to erase this one, can we use it? I'm going to Can we use this student name as a primary key?
No. No.
Why?
There are two
There
Yeah, there are two.
are common names.
Sorry, there are two common records as Kamal and Kamal. So we cannot identify each and every records uniquely. So what about this field? This is also two records as Madra, two records as Kagala. We cannot identify each and every record. So the primary key is a key which is used to identify the each and every record. So you need to have some idea about how to choose a primary key for a table. I think it is clear. Then, okay, this.
Excuse me.
Okay, go ahead.
So primary key means the rows or the tuples are different. It means
Sorry, rows and the tuples are
different to each and everyone. The rows or the tuples are different for a primary key.
Yeah, by using primary key, we can
Okay, thank you.
each and every tuple. So you can see no duplication. This is very important. No duplication values for the primary key. So S1 is belongs only to Kamal. No one can have this S1 ID. Okay. This is about primary key. So when we consider about this primary key, you can see one attribute contribute to create a primary key. In this scenario, one attribute contribute to create a primary key. Okay. So, but there are some cases more than one attribute get together to form a primary key. We will discuss these examples. That means example for this in upcoming lecture. So keep in mind, there are sometimes more than one attributes contribute to create a primary key. At that time, primary key is known as composite key. Okay, so primary key is a primary key if it contributes one attribute to create a primary key. Otherwise, that means more than one attribute, it is known as a composite key. Okay, so in this relational model, you can take, this is the relation lecturer, this is the course. There are some attributes as a lecturer ID, lecturer name, and the course ID. This is course ID, course name. So primary key can be underlined. So this is underlined. This is the way you can represent a primary key. Yeah, don't confuse with composite key. We are going to discuss about this composite key with this ER diagram. Just keep in mind to form a composite key, more than it contribute more than one attributes. ඒ කියන්නේ අපි ගත්තම දැන් primary key එකේ අපි හදන්නේ එක key. දැන් අපි මෙතන example එකේ you can see in this example only one attribute taken as a primary key. If you take more than one attribute, or if you took more than one attribute as a primary key, this primary key is known as composite key. There are some cases with there are some cases in that cases the two attributes are get together to form a primary key. At that time, this primary key is known as composite key. Don't confuse with this. I'm going to explain this composite key again in this entity relational model, so no need to confuse. So you can see we can underline the primary key. So the primary key has been underlined. The practice, we would use an identify number rather than the name of the key field of each relation, since it is possible to have a two lecturer with the same name. So this is example. In this case, this is the primary key. Okay. These are some restrictions will be applied to the table. So In this case, no two rows in a relations are identical. So you cannot have two rows as 0, 0, 3. So in this relations, no two rows are identical. Then in this case, when we consider about the values, that means values for this. As example, let's take this one. It only has a single value. When we consider about value for a course ID attribute, it can, that means it can have a single value. It can has a single value. So the any domain value in the occurrence of the tuple is atomic with respect to the set of values on which the domain is defined. So multi-values are not allowed for the attributes in the relations. So you cannot. Can you all hear me clearly?
Madam, voice is breaking time.
What about now?
Yes, we can hear.
Okay. Wait, I'm going to share the screen with you. Okay. Then you can see any domain value in an occurrence of a tuple is atomic with respect to a set of values on which the domain is defined. That means multiple values are not allowed for the attributes in a relation. So the multiple values are not allowed. So these are the characteristics. No need to discuss about these things. You can go through it and get some idea about what are the advantages and disadvantages of this model. Then let's move into our next model. It is about entity relational, that means entity relationship model. In this case, in ER, this is known as entity relation, shortened form of entity relation is ER. In ER model, you can, ER model is a graphical tool for data modeling. So when we consider about this ER model, it is a graphical tool for data modeling. In this model, it describes the graphical representation of an entity as well as their relationship. So the entity relationship model is a graphical tool which is used for data modeling. In this case, it is described the graphical representation of an entity as well as relationships. Okay, I'm going to this one. So when we consider about this ER model, we use ER diagrams to represent. So ER model normally represent by using the entity relationship diagram. So entity relationship diagram is known as ERD, that means ER diagram. So this is ERD diagram, that means ERD uses for graphical representation to model the database component. So before moving into this ER diagram, we need to identify each and every component in a ER model. The first one is entity. So when we consider about entity, it is a person or a place or a thing about which data are to be collected or stored. So in this case, this entity is a person or a place or a thing which data are to be collected or stored. So as an example, we are going to collect the information about university students. So the student is the entity. So we are going to find the information about customer. So the customer is the entity. So we are going to find the information about invoices. So the invoice is the entity. So this can be a person or a place or a thing. Okay. So we can represent this. That means we can represent this entity by using a rectangle. So you can use a rectangle to indicate, or you can use this rectangle to represent an entity. So when we consider about this student, you can represent this student in this rectangle, but with the capital letters. Mostly we use these capital letters to written the entities, and it should be in a singular form. When we consider about the, as example, let's take, we are going to find the information about students, but the information is based on students, but we define this entity as student, like this, in a singular form, not in a plural form. Okay. So this is about entity. Then let's discuss about relationships. So when we consider about relationship, it describes the association among the data. That means this is describe the relationship among two entities. Okay, so in our first case, students. So there is another entity as course. So the relationship between these, so association between these two entities is known as the relationship. Okay. When we consider about relationship, there are three types of relationship as a one-to-one, one-to-many, and many-to-many. So the relationship, there are three types of relationship: one-to-one, one-to-many, and many-to-many. Let's discuss about these three in detail. So before that, you can use this diamond shape to represent the entities. Sorry, represent the relationship. So the entity is represented by using a rectangle. Then the relationship is represented by using a rectangle like, sorry, diamond shape like this. So this is the diamond, this is the rectangle, this is about relation, sorry, entity, this is about relationship. Okay, now we are going to, and again there is another thing. So, another thing, when we are define a relationship between these two entities, we use active or passive verb to indicate the relationship. As an example, let's take lecturer teaches course. So the teachers is a verb. It should be an active form or a passive form. This is a verb. So these are nouns now. Entities are nouns. The relationships are verbs. Okay. So in this case, each company department has many employees, and parent paints many paintings. So before moving to one-to-one, one-to-many, and many-to-many, that means type of relationship, can you identify the entities in this first sentences? What the sentence? What are the entities in these sentences? Sentence.
Department and employees.
Department and the employee. I'm going to write it as dep and the employees. So we can use rectangular shape to indicate these two entities. Then what is the relationship between these two?
Has.
Has. So you can use diamond shape. That means diamond. This is called as, I think, diamond. Yeah. This is the diamond. You can write has inside this shape. Again, there is another relationship. Painter paints many paintings. So what are the entities?
Painter,
Painter
painting.
and painting.
Painter and the paintings. Then the entity like this. Painter. This should be in capital letters. So then the painting. Then what is the relationship between these two entities?
Paints.
Paints.
Paints. Okay. So I think now you have some idea about how to create a relationship between two entities. Then let's discuss about types of relationship. There are 3 types: one-to-one, one-to-many, and many-to-many. Okay, I'm going to take this one. So it will be difficult to understand this one-to-many and the one-to-one by using this example. I will explain it later. Before explaining this one, I'm going to, as an example, let's take 2 entities. Okay. Now we are going to talk about one-to-one relationship. One-to-one relationships. One-to-one means, let's take 2 entities as A and B. In one-to-one relationship, this A has one and only one corresponding entry in the B. So in this case, let's take 1, 2, 3, and 1 A, B, C like this. In one-to-one relationship, this A has only one and only A has one and only corresponding entry in the B. You can see this is the corresponding entry. So this is the corresponding entry of this one. So this is the corresponding entry of this one. So you can see one element has one corresponding element. So when we consider about one element from this one, it has only one and only element from this one. So this relationship is known as one-to-one relationship. Then this is about numbers. Now I'm going to explain this with university database. So when we consider about university database, consider the 2 entities as dean and the faculty. Okay, I'm going to take the entities dean like this and the faculty. Okay, so this is the faculty. So there is a relationship between this dean and the faculty. This relationship has relationship. That means dean has, sorry. Yeah, this should be changed. I'm going to, that's, yeah, wait. Can be taken like this, but I think this was clearer than that. In this case, this is the faculty, then this is the dean. So faculty has dean, okay? So when we consider about this relationship, the faculty and the dean relationship, one dean is whole, that means one faculty has only one dean. When we consider about one faculty, as an example, management faculty. In management faculty, it has only one dean. When we consider about natural sciences has only one dean. So when we consider about the relationship between the faculty and the dean, one faculty has one dean. So when we consider about a dean, one dean can hold a deanship only for one faculty. So one dean can hold a deanship for one faculty. So this is also one, this is also one. This relationship is known as one-to-one relationship. Okay, is it clear?
Yes.
So give me some example. Okay. After that, okay, wait. Okay, then let's discuss about one-to-many relationship. Okay, this can be one-to-one is one. You can take any no m for one-to-many. So in this case, wait, this is about one-to. Okay. In this case, let's take again A and B. In this A and B, you can see if A has like this. So if A has a relationship to B such that many entries in B can refer to one entry in A. That means like this. So in this case, A and B has a relationship. So the B can refer the many. B can refer. Wait. Onto many relationships. In this case, A and B, so A, B, C. In this case, like this. In this case, B can refers to one entry in A. So B, when we consider about this relationship, it has a relationship like many entries in B can refer to one entries in A. Okay, so let's take an example as faculty and the lecturer. So when we consider about faculty, this is the faculty and this is the lecturer. So this is has. So when we consider about one faculty, it may have many lecturers. But when we consider about one lecturer, he or she belongs only for one faculty. So this relationship is equal to 1 to many. No need to write this. Just keep in mind like this. When consider about this faculty and the lecturer relationship, faculty may have many lecturers, but each lecturer is joined only for one faculty. So this is known as one to many relationship. Is it clear?
Yes, madam.
Okay.
Yes.
Next one is many to many relationship. In this case, again, M, A and B. This is 1, 2, this is A and B. Then you can map to many entries. You can map to many entries like this. So as an example, let's again take some example with the university database. The relationship between lecturer and the student. So lecturer and the student. This should be in capital letters, okay? Lecturer and the student. The relationship is known as teacher. So when we consider about a lecturer teaches for many students. So when we consider about one student, he or she is taught by many lecturers. Okay, one lecturer teach for many students. When we consider about one student is taught by many students. So this in this side the maximum value is m, in this side maximum value is n, this is n. So many to many relationship. Is it clear?
Yes.
If you have any doubt now, you can raise your questions. I will give you 1 or 2 minutes to ask question.
When we are writing many to many, the symbol should be M and N, is it?
Yeah, m and n. Many to many. This one. Sorry. This can be m to n or m to n. No problem of this. 1 to many. Mn used to denote the many. Okay. So you can use MON as first. Again, MON.
Okay, ma'am.
Many to many relationship. Okay. I'm going to explain it again. This can be taken as M to N. Both are correct. One to one, then the one to many. This also can be taken like this. One to N. Okay. I'm going to explain this one again. Wait. You can say in many to many relationship. Okay, in many to many relationship. As an example, let's take lecturer and the student. So this is the entity lecturer, and this is the entity students. So lecturer teach for students. Okay, this is the relationship. So when we consider about one lecturer is, that means a lecturer teach for many students. Lecturer teaches, each lecturer teach for many students. When we consider about a student is taught by many lecturers. Many lecturers. As an example, teaching for many students, and you are taught by many lecturers. Okay, I am teach for many students. Altogether there are 112 students now. So I'm teaching for many students, and when we consider about one student, this one student is taught by one lecturer. In DBMS, one lecturer. In data structures and algorithm, another lecturer. In Java, another lecturer. Likewise, one student is taught by many lecturers. So this can be taken as n. Okay, one to n, one to many, then one to many. In this side, the maximum one is n. In this side, n. So this relationship is m to n relationship. Is it clear? In previous example, this one, faculty and the lecturers, you can take it like this, has one faculty has many lecturer. When we consider about one lecturer, she or he belongs only to one faculty. So in this case, maximum value is 1. In this case, maximum value is m. So this relationship is 1 to many relationship. In this case, maximum value is m. This is n. So many to many relationship. Likewise, you can define your one to many and many to many. Okay. In one to many, again, okay, good, thank you. Okay. So in the faculty, when we consider about one faculty can has many lecturers. As an example, in the natural science faculty, you can see there are so many lecturers. Some lecturers from computer science department, some from zoology. Likewise, there are so many lecturers belongs to one faculty, that means natural science faculty. So one faculty has many lecturers, but when we consider about one lecturer, he or she belongs only for one faculty. So this relationship is one to many relationship. Is it clear? Is it clear?
Yes, ma'am.
Okay.
Yes.
Okay. Identify the, I'm going to give some example. So this should be a capital student. Wait. Student. When you are, as an example, let's take a student. So students follows, when we consider about you follows many course. So what is the relationship between these two entities? Identify the relationship between these two entities, student and the course.
Many to many.
Many to many.
Many to many.
Many to many. What about others? Is it clear? Sorry, is it true?
Many to many, ma'am.
Someone say it as one to many. Then Sansa said it as many to many. One to many. Again, one to many. Let's take. When we consider about this, I'm going to take another color, okay? There are two answers for same question. One. So when we consider about one student, okay, this one student follows many courses. As an example, Rashmika follows computer science database. Okay, again data structure. Likewise, one students can follow many courses. When we consider about one course, when we consider about this one, database designing and implementation. When we consider about database design and implementation, are there in one student in this course? How many students in this course?
Many.
Many. So when we consider about course can have many students. So this relationship is one to many. Sorry, many to many. Is it clear?
Yes.
Yes.
Okay. Let's discuss some more example in entity relation ER diagram. Okay. In this case, one student follows one subject combination. In this case, they taken it as one student follows one subject course, and one subject course is a combination is followed by many students. Okay, so one subject course is followed by many students. So we can put one student follows one subject. One student follows one subject, and one subject combination is followed by many students. So it's only depicts the one side relationship, not both. In this example we discussed about both. In previous example we discussed about both. That means how to take the cardinality. So this is before the cardinality. Okay, don't confuse with these things. Okay, give me 1 second. This is about so that example is like this. Student, when we consider about one student learns many course. When we consider about one course, it is learned by many students into a many to many relationship. Okay, last discussed example. Okay, then these are the advantages. No need of doing it again and again. You can go through these advantages and the disadvantages. Then let's move into our last session from the previous week. This is about object-oriented data model. So in this case, so with the time, the real world problem becomes more complex and it leads for need a different data model based on the real world representation. So this object oriented data model was inverted as a result of that. Okay, so you can see in this model the basic structure is a object. When we consider about object oriented model, the basic structure is a object. So the object are the abstraction of the real world entities or a event. So we can associate with the real world entities. These entities are known as objects. So when we consider about this object, the basic data structure of this object-oriented model is object. These are real world associations. So when we consider about object, this is just like a entity in ER diagram. In the ER diagram, we discussed about entities. This object are same as entity in ER diagram. But object represent only one individual occurrence of an entity. When we consider about object, this object represent one occurrence of the entity. This object is just like the entity, but when we consider about object, it is represent one occurrence of the entity. Okay, I'm going to discuss it with the example. As an example, let's take so the objects are abstractions of the real world entities or an event. So you can see these objects represent only one individual occurrence of an entity. As an example, let's take student. So Rashmi is the object of this entity. Okay. Yes, I'm going to upload these records to Learno USA. Don't worry about it. So when we consider about Rashmi, Rashmi is the object of this student entity. Okay, Rashmi is one student in this class. Okay, so when we consider about this object, when we consider about object, attribute describe the properties of an object, and the method describe the action made by the object. As an example, let's take a person. When we consider about a person, so don't take it as a person. Let's take it as a student. So when we consider about the student, there are some characteristics or the properties of the students. In relational model, we take it as attributes. In ER model, same as attributes, but in object model, so yeah, attributes in object model, same as attributes. This attribute describe the characteristics of an object. As an example, let's take the student. So this is the student entity, Rashmi is the object. So when we consider about student, she or he has a student name, then the student ID. Then the date of birth. These are known as attributes. This attribute describes the properties of an object. Then about method. So when we consider about method represent the real world action. That means the finding a student's name, then following a course, then facing for the exam, face for an interview. Likewise, there are some actions. So these actions are known as behavior of the object, and these are known as attributes are known as properties of the object. So finally, we can take object. This object has properties and the behaviors. These properties are known as attribute. Behaviors are known as method. Okay, this is about object. Is it clear? Before moving to class, is it clear? Okay, then you can see then again we are taking a classes. So to build a class, similar characteristics are grouped. Objects that share the similar characteristics are grouped into a class. So in previous example, I took Rashmi as the object and student as the entity. So in this object-oriented model, we can take student as the class. Student has as the class. Okay. So wait. In this case, in previous case, I took Rashmi as example. Then Rashmi has name as Rashmi. Then age 22. Then address Matara. So again, there is another object as Chanika.
Excuse me.
It.
Here the objectives divide as behaviors and the other word starting from P what?
Sorry, I can't hear clearly.
Here the objectives starting from objectives, it's divided to two behaviors and the other word is what?
Properties. This is about
okay.
This
Okay.
is behavior. Sorry.
Okay. Thank you.
My handwriting is not clear. That's why. So this is properties and this is behavior. So Rashmi, when we consider about Rashmi, it is an object. So Rashmi has the name and the age and the address. Then another example as Chanika. Chanika has the name as Chanika. Then the age and the address Kalania. Likewise, there are many students. Altogether 109 students in this class. So there are 109 objects can be found in this class. So when we consider about this object, all these have same properties. All you have a name and the age and the address and date. That means NIC number, student number. Likewise, you have some common properties. So by all the objects that share the common properties or characteristics are grouped into a class. So we can define this class as a student class. So in student class, Rashmi is an object and also Chanika is also an object, and there are some other objects. Okay. So the common name for a group of objects which share the same characteristics is known as student. Is known as class. Is it clear? Can you differ? Is it clear? Student,
could you please repeat that again?
Okay. So as an example, we can take Rashmika. When we consider about Rashmika, she is a object. Okay. As an object, we can take a Rashmika. You can take Rashmika. When we consider about Rashmika, Rashmika has a name, then she is 23 years old, then the address Mathur. Then we can take another object. In this class, Chanika. When we consider about Chanika, 22 age from Kalani. Likewise, you can see now there are 106 participants. That means 105. So you can see 105 students in this class. So there are 105 objects in this scenario. අපි ගත්තම අපේ ක්ලාස් එක ඔයාලට පේනවා 105ක් තියෙන ඔබ්ජෙක්ට්. මොකද මම කිව්වනේ රශ්මිකා කෙනෙක් නා ඔබ්ජෙක්ට් එකක් විදිහට ගන්න පුළුවන්. එයාට characteristics තියෙනවා. රශ්මිකාට දුවන්න පුළුවන්, කන්න පුළුවන්, බොන්න පුළුවන්. So රශ්මිකාට behaviors උත් තියෙනවා. So අපිට කන්න පුළුවන් රශ්මිකාව ඔබ්ජෙක්ට් එකක් විදිහට. දැන් චානිකා කියලා කෙනෙක්ව ගත්තත් එයාටත් ඒ properties ඒ විදිහටම තියෙනවා. එයාට නමක් තියෙනවා, එයාට age එකක් තියෙනවා, එයාට address එකක් තියෙනවා. එහෙම තියෙනවා. ඒතකොට දැන් අපේ ක්ලාස් එකේ ඉන්නවා මේ වෙලාවේ 105ක්. ඒතකොට අපිට මේ 105ම ඔබ්ජෙක්ට් 105ක් කියලා ගන්න පුළුවන්. හැබැයි all these objects share the similar characteristics. Definitely all you have name and the age and the address. ඔයාලා හැමෝටම name එකක් තියෙනවා, address එකක් තියෙනවා, age එකක් තියෙනවා. මෙන්න මේ object සේරටම අපිට මෙන්න මේ object ඔක්කොටම, so the collection of this object can be called as a class. අපිට මේ ඔක්කොටම class එකක් කියලා කියන්න පුළුවන්. This class is a student. So when we consider about student class, all you are object of this student class. Is it clear now?
Yes, clear.
Yes, ma'am.
Yes, madam.
When we consider about another example, you can see there are so many car types. It's Benzes, BMW, likewise, there are so many car types. But commonly we can say all these car as a car. So this is, so that means Alto is belong to car class. Then the Alto is the object, car is the class. Okay. Clear?
Yes, madam.
Yes, ma'am.
Yes, clear.
Then so one dog object. So when we consider about this one, Tommy, it has attributes. Tommy, 6 years, brown mare. These are the behavior, barks, runs, eats, sleeps. Likewise, these are the behaviors. So when we consider about this one dog, this is the object. But when we consider about generally or commonly, this is the object. So commonly it can be taken into a dog class. The Tommy is the object of dog class. So this is the class in object-oriented data modeling. So this is the that means this is the entities in ER diagram. So in ER diagram, we take student as the so we take this dog as the entity. Again, in this case, in ER diagram, we took this student as an entity. Okay. In ER diagram, we took this student as entity, then the lecturer as entity. But when we consider about object-oriented data modeling, we can take it as a class. Okay. ඒ කියන්නේ ER model එකේ අපි entity එකක් විදිහට මේවා කරපු එක්කෙනාව අපි මේ කියන්නේ object oriented model එකේදී අපි ආව ගන්නේ class එකක් විදිහට. ඒක clearද?
Yes, clear.
Some difference between ER modeling and the object oriented model. Okay. So again, they all the class hierarchy. So the class are organized into class hierarchy. So you can see classes can be, car is an entity in ER, that means ER data modeling, but car is a class in object-oriented data modeling. Okay. This is the main difference between these two models. So when we consider about these classes, we can see this is the class hierarchy. This is the class hierarchy. You can see this is the main one, and this is the parent, and these are the subclass. Don't misunderstand. Wait. Okay. So in this case, there are two classes. Okay. Then I'm going to this one. As an example, let's take the class as person. Again, employee and the student. So when we consider about student, this employee have name. Then employee has a name, and student also has a name. Then age. So in this case, they have some course ID. In this case, they have some employee ID. Likewise, so you can see there are some common attributes between these two classes. There are two classes as the employee class and the student class. There are some common attributes as the name and the age. So these name and the age are common for these two classes. So at that time, we can make another class as a person with this common attribute. So name and the age. So you can create a class by using the common attributes of these two classes. Okay, then we are going to delete these two from this one, then the employee ID, then the destination, then the student ID, then the course and the grades likewise. So you can see these are the properties of this class.
Excuse me.
Okay, go ahead.
Excuse me.
Okay.
Could you please explain this diagram slowly a little bit?
Okay. Okay, I'm going to explain this one, okay, with an example. I think it is very difficult to get some idea about this example, the same example. So, as the example, when we consider about a person, okay, let's take a person. First, we are going to take a person. When we consider about person, or the person has NIC number. So this is a property or a attribute. This is a property. Then that means attribute. When we consider about name and age and also yeah, these three. This person has these three properties. So when we consider about employee class, and there is a class like employee and like student. So when we consider about employee also have a NIC number, okay? NIC number. And employee also has a name and also age. Apart from these things, there are some other properties like employee ID. I'm going to write these things in red. Employee ID, again, designation. Okay, in this case, these are the properties of the employee: NIC, name, age, employee ID, and the designation. So when we consider about person, these are the properties of the person class. Then student. So when we consider about the student also consists with NIC, then the name and the age. And also student has its ID, then courses, then which one? Grade, like this. These are the properties of the student class. So there are three classes as a person and the employee and the students. These are the properties of the person class. These are the properties of the employee class, and these are the properties of the student class. So when we consider about these three properties, you can see these three again. These three also available in this class. Again, these three available in this class. So when we consider about these two, you can see some common attributes. These are common attributes. So at that time, we can define, or we can make a relationship to this class. This class only has these three properties. So at that time, we can make a relationship to this class. So in this class, these three properties are available. Now this class available with this, but it has a relationship with this class. So this employee can inherit these three relationship. Okay. So these three properties. In this case also, student has these three properties. So these three are common. Altogether, these three are available with this person class. I'm going to delete these three properties from this one and create a relationship. At that time, this class can inherit the these three properties from this person class. Okay. ඒ කියන්නේ මෙහෙම. දැන් employee ගේ class එකේ attributes 6ක් තියෙනවා. NIC name age කියන එක පොදුයි. student ගේ class එකේ තියෙනවා NIC name age කියන එක පොදුයි. අපි කරන්නේ මෙන්න මේ common attributes ටික දාලා හදා ගන්නවා class එකක් person කියලා. එතකොට මේකේ තියෙන මේ common attribute ටික විතරයි. එතකොට මෙන්න මේ employee ට පුළුවන් අපි modeling වලට යද්දී කියන අපි ER diagram වලට database හදද්දී අපිට පුළුවන් all of Java එහෙම කරනවා නම් මේක හොඳටම පුළුවන් වේ. So මෙන්න මේ class එකට පුළුවන් මෙන්න මේ properties තුන මේවා කරන්න මෙයත් එක්ක relationship එකක් තියෙන නිසා. ඒ relationship එක කියන්නේ අපි relationship එකට තමයි inherit කරනවා කියලා කියන්නේ. So in this case also this student has a relationship with this person class. So this student class can inherit the person details or a person properties from this class. Okay, is it clear now?
Yes, clear.
Yes, madam.
What about others?
Yes, madam.
Yeah,
Yes, madam.
I feel level.
Yes, madam.
I think you are going to discuss more and more in Java. It's an object-oriented programming. So this is about classes and the inherit properties. So you can see classes are organized in the class hierarchy. The class hierarchy remembers. For example, customer class, employee class share the parent person class. Okay. So you can see the same example. I'm going to replace student. So you can see this is the common class for that means this class has common attribute for both classes. So this is known as a parent class. This is known as a child class. So again, we can call it as a super class. This is as a subclass. So this is parent, then these are child. So this is the super class and these are subclasses. Okay. So this subclass has ability to inherit the properties from the super class. Okay. Inherit is that a class within a class hierarchy to inherit the attributes and the methods. I only discussed about the attributes. So again, we can define some methods for common method for this person class, and these two classes can inherit common method also. So for example, we can create two classes as a customer and the employee as a subclass from the class person. In their customer and employee will inherit all the attributes and the method from the person. So always this superclass is consist with common attributes and the methods for both class. Okay, this is consist with common attributes and the common methods. I think it was clear. Do you have any questions?
No, madam.
About others? Now it's all 44. Then when we consider about our next session, it is about evolution of data models. So no need to discuss about that lesson. It's a repetition of all these things. So you can go to that lesson in page number 45. I think you can see a table with disadvantages and the advantages of various data model. You can go through this table and get some ideas about the advantages and disadvantages. Then let's discuss about ER relationship, that means ER model again. Now we are going to discuss about lesson number 8, ER modeling. This one I'm going to upload this. Yeah, I will upload these slides into Learno USL as soon as possible. Then let's discuss about ER relationship. So the ER relation, that means ER diagram. Before moving to the ER diagrams, let's discuss about ER modeling. So ER means shortened form for entity relationship. Okay. So now we are going to create. We already discussed about different types of, yeah. I think this is session number relation of data models. Yeah, this is lesson number 8, entity relational model. Now we are going to create a relational database. Now we are going to create a relational database. To create a good relational database, it is needed to have some simple steps, or it is needed to follow some simple steps. So to create a good database, it should be with the minimum data redundancy. So this is very important. If you need to create a good database, so it is needed to be with minimum data redundancy. So the data redundancy can be insert one or an update one or a deletion anomalies. So this can be insertion anomaly, then update anomaly, and the deletion anomaly. Background noises. Okay. Okay, so when we consider about this good data database, it is needed to have a minimum data redundancy. So the data redundancy cause insertion, update, deletion anomalies. So to avoid such anomalies, when you are designing a database, you need to follow some steps. So these are the main steps. The first one is analysis. Then the second one is conceptual modeling and the designing. Then the last one is logical modeling and the designing, and last one is implementation. Let's discuss about the first step. This is about analyzing. When we consider about this analyzing is consist with 3 parts as planning, requirement gathering, and the feasibility study. So when we consider about analysis phase, it is consist with planning, then requirement gathering, then feasibility studying. So when we consider about the planning stage or a planning steps, at that time we are in this stage we can have a proper plan about the designing of the database. That means what is the database type and how we are going to design this database. So what are the information we need to create a database, and what are the tables. Likewise, this we plan about our database. We can get the rough planning about our database in this planning phase. After that, we are going to gather the requirements. In this step, we collect the information, and we decided what are the tables and how we can create the tables. So what is the software we use to create a database. Likewise, we can gather the information about data in this requirement gathering phase. After that, the next one is feasibility studies. When we consider about this step, this is the step where we decided whether we are going to build the database or not. So in this case, the planning case, we are planning about the database. What is the database? What are the data sources, and how we can create it likewise. We can have a pre-planning about the database in the planning stage. Then we collect the information about the database. After that, in the feasibility study, in studies, we check whether we decided whether we are going to build the database or not. If you pass this analysis step or this step after passing this stage, that means this stage, that is now you are going to create a database, and then you need go for the conceptual design. So all the data, all the required data are already collected, and you decided whether you are going to create the database or not. After that, that means if you if you pass this step, then you are that means then you need to go for the conceptual designing. So you can see in this case, conceptual modeling. Now we are in conceptual modeling. To build a conceptual model, it is needed to have some idea about ER diagrams. So now we are in conceptual designing. So when we consider about this conceptual designing, in this step or stage, you identify the data requirement and the data relationships and how they can represent in graphical format. So this is the place where you identify the data requirements and the data relationships. So this is the place where we need a ER model. So this is the graphical representation stage. So this is the conceptual model. This is the graphical representation. ER diagram is the graphical representation. So after analyzing, we go for the conceptual modeling. Under the conceptual modeling, now we are going to discuss about ER diagrams. That means how you can represent the entities and the relationship. Okay. This is now. Okay. So when we consider about this ER model, there are some components in the ER model. We already discussed about entity and the relationships and the types of the relationships. Okay. So the first one is most of the concept and the definition used in the ER model were introduced in early lessons. Okay, we already discussed about entity, then the relationship, and about primary key and so on. We discussed about so many things about ER diagram. So now we are going to discuss about the graphical depiction of the relationships among the entities and the ability to summarize the wealth of the information required to implement a successful design. Okay, we already discussed about entities, then the relationships. Now we are going to discuss about how we can graphically depict the relationship among these entities. So to model this one, it is needed to have a ER diagram or the OERT, that is the shortened form of ER diagram. Okay, so this ER diagram represents the conceptual database as viewed by the end user. So this is the conceptual database. We already discussed about this thing. This is the conceptual database. In conceptual database or in conceptual model, we only discuss about what is represented in the database rather than how it is represented. Okay. So Now we are going to discuss about ER diagram. So when we consider about ER diagram, this ER diagram is consist with mainly three components. The first one is entities, then the next one is attributes, and the last one is relations. So ER diagram is based on these three components. So as an example, you can see an entity represents a real world object, definitely, and the word entity and the objects are often used as interchangeability. So as an example, always this entity represent a real world object, and when we consider about entity, it is a noun or a place or a thing. Okay, so you can see this is the example. This example is about the entities of XYZ University, include the student, class, teachers, and the classroom, and so on. An entity at the ER modeling level actually refers to an entity set, not a single entity occurrence. We already discussed about this. When we consider about these students in ER diagram, we only represent this as a student in the singular form. But when we consider about the singular form entity, it represents the plural form of this noun. Okay, so it can always it represent more than one occurrence. Okay, not a single occurrence. So the word entity or an entity set in ER model correspond to a table in relational model. So when we consider about ER modeling and the relational model, this entity is corresponding to a table in the relational model. We already discussed about many data models, object-oriented data models. So in this case, relational model, it's a table. In ER diagram, it's an entity. Then in object-oriented model, what is the similar components in the object-oriented model? In ER diagram, it's an entity. When we consider about relation model, this entity is known as a table. But when we consider about object-oriented model, how you can define this entity?
Class.
Class. You can define it as a class. Okay. So when we consider about the entity is represented by a rectangle which contain in the entity's name. Entity name is a noun. We already discussed about this. Then about attributes. We discussed about attributes, but we didn't discuss about how we can represent these attributes. So I think it's now 4:58. 58. We discuss this. We will discuss these things in our next lecture. Before that, do you have any questions up to now? Is it clear, or there are some still you have doubt?
Madam, the last point there you told that it's represented by a table. That part I didn't understand.
Okay. So when we consider about entity in this one, when we consider about entity, normal real world noun is known as an entity. So when we consider about entities like student, course, university, this entity in ER model. ER model entity. When we consider about relational data model, this entity is known as a table. Okay. ER model entity එකක් විදිහට අපි represent කරන එක, relational model එකේ අපි represent කරන්නේ table එකක් විදිහට. In ER model we represent this as an entity, but in relational data model we represent it as a table, because the basic data structure of the relational data modeling is a table. In ER modeling, it's a entity. When we consider about this one, object-oriented model, this entity is known as a class. ඒ කියන්නේ අපිට දැන් ER model එකේ entity එකක් අපේ relational model එකට යද්දී අපි ආව හඳුන්වන්නේ table එකක් විදියට. අපි object oriented model එකට යද්දී ආව class එකක් විදියට. හරිද?
Yes, madam, understand.
Do you have any other questions?
Madam, when we get the hard copies of our course material,
I don't have any idea about that issue. I will discuss it with Duminder sir and let you know. Uta, you can contact dispatch, I think, no? CRC. You can.
Madam, today I called dispatch unit. They told me that they will check and may give me a call. But evening, when I called them, they have switched off the phone.
Okay, I will discuss it with Duminder sir and let you know. Okay.
Okay, madam.
Are there any other questions? No questions? I will give my email address. Okay. You can directly contact Miss Hirunika. I think Hirunika, yeah. Post the wait.